Lesson 99, Uniform Motion, Unequal Distances. So up until now, everybody that we have talked about in our distance or motion problems have traveled the same distance. They have just traveled at different speeds. So we're going to change that a little bit and talk about different distances and how that relates to our dirt formula and what we're going to do. So let's jump right in with an illustration. We're going to start with 99.1, and we're going to go back to the ancient Greeks and talk about Achilles and Petroglyphs, however you say his name. So at 8 p.m., that's important, or else they wouldn't tell you. So at 8 p.m., Achilles left camp and headed south at 20 kilometers an hour. So 20 kilometers per hour. At 10 p.m., Patroclus left camp. And by 3 a.m., he was 50 kilometers ahead of Achilles. So let's draw a little diagram. So here's Achilles, and here's Patroclus, right? Achilles is traveling along. He's going 20 kilometers per hour. Patroclus left 2 hours later, and he is 50 kilometers ahead. So Achilles' distance is, or actually Patroclus' distance is Achilles' distance plus 50. And we know that Achilles traveled for 7 hours. That's their rate. And Patroclus traveled for 5 because he left 2 hours after Achilles. And we know that the, I'm sorry, that's not the rate. That's the time. The time was 7 hours. The rate for Achilles was 20. We do not know what the rate for Patroclus was, and that's what we're going to find out. So we start by making a distance problem. We know that the distance of Patroclus was equal to the distance of Achilles plus 50. We can see that here. Now, given that we know that distance equals rate times time, we can change this up a little bit, and we can say the rate of Patroclus times the time of Patroclus equals the rate of Achilles times the time of Achilles plus 50. Okay? So we can see how we can drop those things in. This is what we have to find out. What was the rate of Patroclus? So we can drop in, we don't know what the rate of Patroclus is, but the time of Patroclus was 5. The rate of Achilles was 20, and the time of Achilles was 7, plus 50, right? So we have 5 times the rate of Patroclus, and I just like to write my whole number in front of my variable. And that's 140 plus 50, which equals 190, right? So 190 divided by 5 gives us the rate of Patroclus, and that's going to be 38 kilometers per hour. Okay? That was pretty straightforward. That was an easy one, so we can put 38 up here. So now we have all of our information. Let's do another one. That one was pretty easy and pretty straightforward. So let's see if we can do another. Let's do 99.2. I'm going to read the problem through first. Rachel has a 15-kilometer head start on Charlene. How long will it take Charlene to catch Rachel if Rachel travels at 70 kilometers per hour and Charlene travels at 100 kilometers per hour. All right, so let's set that up. Rachel and Charlene. Only Rachel didn't start here. Rachel started here. That's 15, right? They both want to end up at the same spot at the same time. That would be the same thing as Charlene catching up to Rachel as they get to the same point. Okay, so the distance of Charlene equals the distance of Rachel plus 15. Okay? Given what we know, that distance equals rate times time, or dirt, we can say that the rate of Charlene times the time of Charlene equals the rate of Rachel times the time of Rachel plus 15. Right? Can you guys see that? All right, so let's go back and look at it again and see what specifics we can pull out. If Rachel travels at, all right, this is her rate, 70 kilometers an hour, and Charlene travels at 100 kilometers an hour, how long will it take Charlene to catch Rachel? Okay, so we are looking for time. And because they are both going to, Charlene's going to catch up with Rachel, at that time, it will be the same. Both girls will be in the same place at the same time when Charlene catches up with her. So that tells us that we can say the time of Charlene would equal the time of Rachel. Because they're starting, maybe they're starting at different places, but they want to end up at the same place at the same time. So the amount of time is the same, but the speed is different. So we can use this as a substitution method, right? So we can drop in the rate of Charlene is 100, okay? And we can drop in that we don't know what the time of Charlene is yet. The rate of Rachel is 70. And because we don't know what the time of Rachel is either, we are going to just use this variable as the time of Charlene, because TC equals TR. We can drop that in, plus 15. And then we can solve. And we can do that by subtracting 70 from both sides. And that is going to be 30 TC equals 15. So the time of Charlene is going to equal a half an hour. Right? So Charlene will catch Rachel in half an hour. $99.3. In this one, we have two people running on a looped track. And it's simpler if we straighten it out into one line, the beginning of the loop to the end of the loop. But we'll see that in just a moment. 99.3, Harry and Jeanette jog around a circular track that is 210 meters long. Jeanette's rate is 230 meters per minute, while Harry's rate is only 200 meters per minute. In how many minutes will Jeanette be a full lap ahead? So what we want to see Harry's distance and Jeanette's distance, and we want Jeanette to be 210 meters ahead of Harry. Okay, that's because she is going faster. her speed, or her rate, I'm sorry, is 230 and his is 200. Right? The time is going to be the same. Even though the distance is different and the little dots are not at the end here, at the same moment in time, we want Jeanette to be a full 210 meters ahead of him. So because the same moment in time, there'll be a different distance, we can say that the time of Harry is equal to the time of Jeanette. Okay? We know that the distance of Harry is going to be 210 meters behind the distance of Jeanette. We know that the rate of Harry times the time of Harry plus that 210 meters is going to give us the rate of Jeanette times the time of Jeanette. Right? All right, so we can start dropping in information. We can say the rate of Harry is 200, all right, times the time of Harry, plus 210. The rate of Jeanette is 230, and we're going to sub in the time of Harry because we need to have the same variable, and because they are the same, we can substitute that in. So let's subtract 200 from both sides because we want to swim our fish. And then that leaves us 210 equals 30 times the time of Harry. Divide both sides by 30, and we understand that it is going to take 7 minutes for Jeanette to be 210 meters ahead of Harry. Okay? Do we see how we take D equals R times T, and first we figure out our distance differences and how we have to balance them, and once we balance them, then we take that distance and sub in our RT formula for the distance, okay? Then we find something that's equal to swap out, in this case it's time, so we can have the same variable on both sides that will allow us to solve. Okay, we could just as easily have said the distance of the time of Jeanette here. We could just as easily have said that. It doesn't matter as long as we use one of these variables in the end to find out. Okay? If you have any questions, please contact me. That's what I'm here for. That's all I have for lesson 99. And I will see you in lesson 100.